Okay, number 11 says to find the zeros of a polynomial function and give the multiplicity of each zero. Okay, remember the zero is just another word for your x-intercept. Multiplicity is how many times that zero occurs. You could have zeros that are the same. You know, if we solve an equation, we get x equals 2 and x equals 2. That means that zero would occur twice. That is referred to as being the multiplicity of the zero, how many times that zero occurs. Okay, so if we want to find the zeros first, it means that we take the equation and set it equal to 0. Okay, try to factor if the equation can be factored. If it can't, you may need to use quadratic formula or different methods of factoring. But here, I can factor out an x squared, and actually I'm going to factor out a negative x squared. So that would leave me with x squared minus 4x plus 4. Then I have a trinomial here that I can factor into x minus 2 times x minus 2. Okay, so then if I want to find each x-intercept, I would set these factors equal to 0. So as I do that, negative x squared equals 0. Well, I know that's going to give me a solution of 0. But because it's x squared, that means I have two values here. So this has a multiplicity of 2. And then also here I have x minus 2 that I set equal to 0, which gives me x equals 2. The same factor again, we know if we set it equal to 0, it would be the exact same. So I could say that this solution of x equals 2 is a multiplicity of 2. It occurred twice. Okay, it has nothing to do with the value, but it's how many times it occurs. Alright, multiplicity tells us about the behavior of the graph at the zeros. If you have an even multiplicity, it means that the graph touches the x-axis and turns around at that 0. So in other words, let me show you an example. If I have a solution that has a multiplicity of, or that has an even multiplicity, let's say my solution is x equals negative 1, and that's one of my zeros. That means that that graph will touch at that point and then turn around. Okay, or it could be coming from the other direction, but it's not going to cross through. It's going to touch and change behaviors. If you have an odd multiplicity, the graph crosses the x-axis at that 0. So if this solution, x equals negative 1, were an odd multiplicity, let's say it occurred 1 time or 3 times, then at that point my graph would actually cross through. Okay, so it crosses through if it has an odd multiplicity. So for your examples, it says to find the zeros of the polynomial function and give the multiplicity for each 0. State whether the graph crosses the x-axis or touches the x-axis and turns around at each 0. If you have an example like this here, it's already been factored. Okay, so I would have to say set x minus 5 equal to 0. So that would give me one solution of x equals 5. This would give me a solution of x plus 3 equals 0, or x equals negative 3. But how many times does that occur? Okay, since it's squared, this would have a multiplicity of 2. The 5 has a multiplicity of 1, so you'll have to state that on your homework problems. So it says state whether the graph crosses the x-axis or touches the x-axis and turns around. So at the 0, x equals 5, an odd multiplicity, this means that the graph crosses the x-axis at x is equal to 5. Okay, at x is equal to negative 3, because it has a multiplicity of 2, this means that the graph touches the x-axis and turns around at x is equal to -3.